Assalamu alaikum. Today we'll be going over 1.3, which is compression, and we'll be going over lossless file compression, lossy file compression, and file compression applications on how we proceed with compressing file types. Maybe it's a video, maybe it's a image. So we'll be going over all of those, right? So let us begin with lossless file compression. So first of all, let's just go over the idea of why compression is needed, right? So oftentimes you need to reduce a file size, right? You cannot transmit very big file size, right? Take for example, emails have a restriction of 1224 MBs, right? You cannot transfer big files through email, right? And then that is one of the reasons why you need to reduce the file size. Now there are two different kinds of reduction compressions that we call lossless and lossy, right? So in lossless, so as the name suggests, lossless, so you do not lose the actual data, right? As it is written, with this technique all the data from the original file can be reconstructed when the file is uncompressed again, right? And this is important for files where the loss of any data would be disastrous, such as a spreadsheet file of important results. If you want another example, it would be a code, right? So for a code to run, take for example, this is a Python code, right? So for a code to run, you need to have all of its data, right? So unless you have all of its data, the code will not work. Therefore we use a lossless file compression there. When we move on to lossy file, so first of all, this eliminates unnecessary data. So as the name suggests, you lose some of the data, right? Lossless file compression is designed to lose none of the original detail, so that is for lossless. You do not lose any detail. But when you use lossy compression, you lose some of the detail. It is not really that close to the original original content there is, right? So now we go over the file compression application. So first of all, as you have heard of these popular formats, mp3, mp4, right? So mp3 uses a technology known as the audio compression to convert music and other sounds into an mp3 file format. So this compression reduces the file size by about 90%, which means that if, take for example, you have an 800 file size, you turn it down to 80, right? So that is how big it is, 80 to 8. So that is a 90% loss, and that reduces the file size by an immense amount, right? So that is something. There is a loss in audio quality, but it is not so noticeable unless you are someone who's working with sounds and movies and all that kind of stuff. So you do not face such a quality loss, as one would say. Okay, so there's another thing known as perpetual music shaping, right? So what is perpetual music shaping? So, in perpetual music shaping, as you all know, humans can only hear the frequency of 20 hertz to 20,000 hertz, right? So, perpetual music shaping does something that it removes totally sounds that are below 20 hertz and beyond 20,000 hertz, right? That is one of the things it does. And another thing it does is that when there are two sounds, and if there's a louder sound and there's a lower sound, less loud sound, right? Softer sound, as you would say. So it takes away the softer sound, as the softer sound would be using some kind of phase. Since it cannot be heard by a person because of the louder sound, it just removes the softer sound, right? So that is how perpetual music shaping works, right? And this does not affect the quality that much. If you're a normal music listener, it wouldn't affect you personally that much as it would do to someone who is working with multimedia a lot, right? Now we move on to MP4. Okay, so MP4 allows the storage of multimedia file rather than sound, meaning it helps you keep music, videos, photos, even animations being GIFs, I suppose, here, into the MP4 format. So the thing is that videos can be streamed over the internet using MP4 format, and that in the end does not lose any kind of quality, right? And now we move on to photographic bitmap images. Like we studied in multimedia in images, right? So when a photographic file is compressed, so the file quality is obviously affected, right? A common file format, as you all may be aware, is the JPEG one, which is a lossy one. So this indicates that you're losing some of the original data, right? So when you're compressing it, when you're using JPEG compression algorithm, a new file is formed and the original file can no longer be constructed. This indicates that this is a lossy one, you cannot reconstruct, right? And a JPEG will reduce the raw bitmap image by a factor of 5 to 15 in terms of the size, right? And also vector graphics can also go some in under some kind of a compression, but it's not really that important to know that, right? Now we move on to run length encoding. Okay, so run length encoding is a lossless type of a conversion, right? And something to notice here is that let's just go over an example to make it more understandable, right? So you have this example here, right? So you have the string, and assuming that each character requires 1 byte, then the string needs 16 bytes. If we assume the ASCII codes being used, so ASCII codes we have studied in chapter number 1.1, so you can refer to those there, right? Okay, so this means we have 5 characters with the code 97. Why is that so? There are 5 A's occurring and the ASCII code for A is 97. Same way, there are 4 B's occurring and that is 98. 2 C's, 299, and 5 D's, so 5100. So in this sense, you are seeing that rather than having 16, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 bytes used overall, right? So this reduces our memory usage in this sense. But sometimes RLE is not so favorable. Let us assume there is a file ABCDEF, right? If you're going to try using RLE on this, so you will have to write 197, 198, 199. So technically you're increasing the size because you are storing the number of repetitions of each of the alphabet, and then you're also storing the ASCII for it, right? So you're in terms using 3 bytes rather than using 1 byte initially, right? So that is going to be a hit on your memory usage, and therefore sometimes run length encoding isn't that favorable when you're trying to compress a file, compress a word file, right? Oh, my bad. Okay, so lastly, these are all the general methods of compressing files that we have discussed, right? And they're also for very specific types of reasonings, right? So you need to be, lastly, you need to be aware of when to use each kind. If you have sound files, right, and you want to transmit them, so the best way you can do is using lossless, unless the sound quality is really important to the person you're delivering the file to, right? So that really matters. If you have program code, right, so you have program code, you have to transmit program code over, so you're going to use lossless here as well. Why is that so? Lossless is used here in the sense that you need all of the data to be reconstructed when the other person has to run your program. If you have pictures, for perhaps you have pictures or videos, right? So you can use lossy for this, because first of all, when you go through social, if you have to post them on social media, even social media uses some kind of an algorithm in order to reduce the file size, reduce the quality. So they go through a lossless kind of a compression, right? And even if you have to like upload a video onto the internet and the quality does not need to be really great, right? So you're shooting a 4K video and you have to upload it, but you do not require the 4K quality for the viewer, right? So you're just gonna downscale it to 1080p and then upload it. This reduces your file size, right? If you have a very good image from a DSLR, right, but all you have to do is post it on social media, right? So then the social media algorithm is doing the work for you. It's literally using lossy compression and reducing the file size. And therefore, this is how compression really works. It depends from type to type. If you require lossy, you're gonna use lossy. If you require the whole image to image or video or program code or any other thing that you sound file, perhaps if you want the original content of it to be stay the same, right? So you're gonna use lossless. So this was the basic difference. Some terms to remember is perpetual music shaping. So this is a really important term because perpetual music shaping is something that is important in the terms of how it reduces the file size, right? Then you have run length encoding. So run length encoding is a very common thing that they ask in the paper, right? So you might be given something like boxes, right? So you might be given something like boxes, and then you have to use run length encoding on them. So we'll be going over some of the questions related to run length encoding, since it is a very commonly asked question. So this is it for 1.3 compression, and as I pointed out, the theoretical part of this depends a lot upon the situation that you are currently in, whether to use lossless, whether to use lossy. And when you're coming to specifics, you need to be aware of perpetual music shaping, you need to be aware of how run length encoding works. So this is all there is to compression. Thank you for watching.